So, hello everyone. I'm Manny from Oakland University of Technology. The sorry. Okay. So this study, buffer management in construction, is a joint study between my university and University of Auckland. Actually, Vicente used to be my supervisor when I was doing my PhD at UOA, and Cassie was my first student at the master's degree at the same university. So let's start from definition of buffer and giving some reasons why do we need to use buffers in projects. This graph may look familiar to many of you. The vertical axis is showing cumulative progress, and we have time on the horizontal axis. In this case, we have two consecutive activities. And the sloped dashed lines are showing the plans. Normally we consider a constant rate, a fixed rate, and the colored lines are showing the reality. As expected, in reality we will have some deviations from the plans, and these deviations are accumulated along the way, along the chain of activity in the project. These deviations are introducing uncertainty into our schedules. If we think, we can divide this uncertainty into two main parts. Part of uncertainty is through randomness. It's completely uncontrollable. For example, if we are talking about natural disasters, it's out of our control. When it happens, we cannot do anything in this regard. But another part of uncertainty is controllable part, which can be excluded from the plans, from the schedules. Now going back to the discussion in lean construction, we may take three approaches to deal with this part of uncertainty. We may try to stabilize our workflow. We may try to reduce inflow variability. And we may try to improve the performance of downstream activities. As a strategy to stabilize our workflow and reduce inflow variability, we may use buffers in the form of extra capacity, extra inventory, or time added to our schedule to protect the production unit against the variation which is coming from environment, as well as to prevent dissemination of variation from the production unit to its environment. Basically, buffers are helping us to compensate for the variable rate of supply and consumption in each production unit. So they are helping us to smooth out the production. While they are helping us to smooth out the production from a lean perspective, they are not required by the end users. So they are non-value adding component of the projects, and they are waste. So it's very important to have a clear strategy to eliminate or minimize buffers in our project. If we decide to keep buffer in our project, despite knowing its waste, then we need to have a certain buffer design in our project which help us to have buffers optimum. Of course, there have been lots of methods in terms of buffer design. These are some prominent ones, just to give you some ideas what has happened in terms of buffer management. Program evaluation and review technique, PERT, introduced around 1950s. They use 3-time estimates, most likely optimistic and pessimistic, to design buffer. Then we have critical chain project management, introduced by Goldratt. Actually, it was a revolution in terms of shifting the concern from task protection to protecting the whole project. Goldratt was suggesting let's cut a part of estimated time for each activity, accumulate all of these cut times, add to the end of chain of activities or end of project, and call it as project buffer. Then we have a few certain methods, mostly statistical methods, which gives us methods to calculate buffers. The risk aggregation technique using the root square introduced by Newbold, and then normality and assumption for the project completion time, introduced by Heroelen and Demiu-Lemister. Actually, they were saying if we have enough number of activities along the chain, their performance, the probability distribution of their performance would be a normal distribution. So you can use this fact to estimate buffers. Also, we have other group of buffer calculation, buffer design, which refer to a few certain factors to use to design buffer. For example, the reliability and stability buffering approach, introduced by Lee et al. As the name is showing, they introduce reliability and stability as two factors, along with the project type and latency and sensitivity of activities to estimate buffers. Also, Tuchel et al. Introduced adaptive methods. They used two other factors. They said it's better to use the number of precedent activities and resource tightness to have our buffer design. And recently, we have computer simulation-based methods. We have three main paradigms in agent-based modeling, discrete event simulation, and dynamics, which basically we are using a numerical method to estimate buffers. Having all of these, studies are showing still people at construction sites are using informal and intuitive approaches, which says something. Basically, it's not just the engineering aspect of the work, but also we need to look at the culture or social, something close to the main idea of last planner system. We need to look at from the other side. In this study, we tried to find what's going on construction sites with these three research questions. What are the approaches currently being used for buffer management at construction sites? What are the main challenges people feel at construction sites, and how to promote tools and support buffer management by these people at construction sites? We adopted systematizing expert interview. Why this method? Because given the short time frame we had for this study, it provided us with instantaneous communication with the experts and gave us access to their knowledge of action and experience coming from practice. We did a purposive sampling. Through this purposive sampling, we could provide a strong diversity in terms of the number of years of experience and positions people had, which were supposed to had the experience of dealing with buffer management at construction sites. So we conducted 12 semi-structured face-to-face interview. Each interview session was in 1 hour, and we had the interview questions more or less the same as the research questions. All the conversations were recorded, and then we took these recordings to the analysis stage. For the analysis stage, we used a thematic analysis, which means we transcribed all the interview communications, coded the transcriptions, and then tried to find patterns within the codes, and joined the codes together, patterns together to create themes. And as a result, we found 8 main themes, which was 7 themes, which was recurring at construction site. The first one, project realizes the use of buffers as an inevitable component. Interestingly, 100% of our interviewees, 12 out of 12, were using a kind of buffer. They were giving different reasons. You can find the reasons within the paper, but all of them were using a form of buffer in their projects. The second theme was no buffer management method with a holistic view is pursued. Basically, 11 out of 12 interviewees were using CPM, critical project chain. The critical chain is referring to the sequence of activities which gives us the longest completion time. It means if one activity is on the critical chain. Basically, it's not being considered for designing buffer. So there's no holistic view of the whole project. The other theme was no systematic strategy is employed to allocate buffers. Basically, these people were using a fixed % of the estimated time added to the schedule, apart from the importance of the activities and the sensitivity of activities. The fourth theme, the current buffer management methods are not effective. As I told, 12 interviewees, all of them were using buffer, and again, all of them were saying that we still facing with problems with time overrun and cost overrun, which is costly for the projects. Then the fifth theme was the contractual issues may curtail the use of buffers. At least in New Zealand, this is a case that most of the projects are using a fixed price contract, which means no matter of how well they are doing in terms of buffer management, they will receive the fixed amount of money, so there is no incentive for them to do better. The sixth theme, new buffer management technologies are resisted. Interestingly, 25% of the interviewees stated they are not interested in using new technology. Basically, they were saying in one instance, one of the project managers was saying he would prefer to spend the extra money on bringing in an experienced person instead of using a new technology. And the final thing we found was current buffer management tools and techniques are challenging. The challenges could be divided at two levels: organizational level and personal level. You can find the details within the paper. And in terms of how to promote the use of a buffer management tool, through our interviews, we found that there are three main features which can help promoting the use of a tool. First of all, the tool needs to be automated in terms of data acquisition, data entry, and the analysis. Second, people at construction sites prefer a customized tool, have a customized tool. Why is it? Because when we refer them to a general purpose tool, basically they find it very complex. They want something straightforward. And finally, the tool requires to have visual ability, because people at construction sites prefer to have graphs instead of having data sheets. It makes it easier for them to interpret data. So, as the last word, we think there should be a balance between the theoretical goals of lean construction and the practical norms. We found a few commonalities between the projects. The commonalities include cultural, technical, and contractual factors. Some of them is not just about buffer management, like contractual factors can be applied to other aspects of implementing lean. And finally, there were three main features which can support a new buffer management tool based on lean theory. Thank you very much.